Hi everyone, today we are going to start 4.3, which is relate transformations and congruence. A transformation. A transformation moves or changes a figure to produce a new figure. And some examples would be changing the size, changing the scale, a reflection, rotation, and translation. We're going to plot triangle ABC with these vertices, and we're going to transform the triangle and move each of the vertex using this rule. All right, so the first thing I want to do is plot these points. So A is 1, 4, so I'm going to look at 0, 0, go to the right one, up 4, 1, 2, 3, 4, and I'm going to label this A. B is 3, negative 2, so I'm going to go to the right 3, 1, 2, 3, over 2, 1, 2. This is B. And then C is going to from 0, 0, going to the left 1 and going up 1. So this is C, so I'm going to connect these dots. And there's my beautiful triangle. All right, so looking at our rule, it's telling us that we're going to take our original coordinate xy, and to the x value I'm going to subtract 2, and the y value I'm going to subtract 1. So let's look at our new A, and I'm going to call this A prime. So A prime is going to be our original, which is 1 minus 2, comma, and then our y value is going to be the original y, which is 4 minus 1. So if I were to simplify this, my A prime then is going to be 1 minus 2, which is negative 1, and then 4 minus 1, which is 3. All right, we're going to do the same thing with B. So my B prime is going to be 3 minus 2, and the y value is negative 2. I'm going to subtract 1. So my new B prime is going to be 1, comma, negative 3. And C prime is taking my original x, subtracting 2 from it, and taking my original y, subtracting 1 from it. So C prime is going to be negative 3, 0. So now I need to plot these new points. So A prime is negative 1, 3. B is 1, negative 3. And then C prime is going to be negative 3, 0. So here is A prime, B prime, C prime, and I'm going to connect these dots. So if you look from the purple to black triangle, all I did from the purple is drop it down 1, and drop it down 1 and then to the left 2 units. Let's try this again. So we're going to plot our triangle ABC, and I accidentally had the wrong letters. So now plot triangle ABC with A is 0, 4, B is 1, 2, and C is negative 1, 4. So I'm going to plot this again. So A is 0, start at 0, 0. I'm not going to move left or right, but I'm going to go up 4. B is going to be 1, 2. And C is negative 1, negative 4. So this is A, this is B, and this is C. All right. Now I'm going to look at my new rule here, and if you look, our original xy, we're going to keep x the same, but we're going to multiply y by 2. So we're going to see what this does to our figure. All right, so A prime then, I'm going to keep x the same, and then I'm going to multiply y by 2. So 4 times 2 is 8. B prime, I'm going to keep x the same, which is 1, and I'm going to multiply y by 2, which is 4. And then C prime, I'm going to keep my x the same, negative 1, and multiply y by 2, which is negative 8. So now I'm going to plot these new points. So 0, 8, it's going to be all the way up here. This is A prime. B is 1, 4, 1, 2, 3, 4. And then C is negative 1, negative 8, which is actually, sorry, down here. I'm not good at drawing straight lines. So there we go. So we can see that the purple triangle stretched to become the black triangle. And so this translation actually changed the size of our triangle. Rigid motion or isometry is a transformation that preserves the length, angle measures, and area. So it just means the shape does not change. So in our first example where we just moved our triangle to the left and down, that was a type of rigid motion. We didn't change the size of the triangle, we just moved it around. However, the second example where we multiplied y by 2, we saw that our triangle got longer, and so we changed the size. So we're not talking about changing size for the rest of this lesson. It's all about keeping the size the same and just moving or flipping or turning our triangle. So here are the different types of rigid motion. Reflection, which is just a flip, a rotation, which is a turn, and a translation, which is a slide. So two geometric figures are congruent if and only if there is a rigid motion or a combination of rigid motions that move one of the figures onto the other. So let's describe the transformation that we can see that moves the blue figure onto the red figure. So if we look at A here, we notice that the blue figure is moving, and we see an angle here, as we see with this. So this here would be a rotation, a turn. And it's a rotation around point P. If we look at part B, we notice that our triangle slides over to become the green triangle. So that would be a translation, a slide. And then we notice that the green triangle flips over this line to become the red triangle. It's like a mirror image. And so that would be then a reflection. For the next problem, we see that the blue figure slides over to become the green figure. So once again, that's a translation. We see an angle here, and the green figure is rotated to become the red figure, and so that is a rotation. And then finally, if we look at this blue figure, we see a slide to become the green figure, so that is translation. From the green figure to the red figure, we see a flip over this line. So this would be a reflection. And you can see it's a mirror image. All right, next we're going to explain why figure A and figure B are not congruent using the transformations. All right, so we see figure A here. The dots are the transformation. So it looks like we had a rotation here and then a reflection over this line. And if we line up our figure A we see that it doesn't necessarily match up with our figure B. So since they do not match up, their sides are not congruent, our angle measures are not congruent, these two figures are not congruent. So they're not congruent. Tell whether a rigid motion can move figure A onto figure B and explain. If we look at A here and B, are these the same size? The answer is no. So they are not congruent. They are not the same size. So a single transformation could not make A look like figure B. Identify the transformation you can use to move figure A to figure B. All right, so it kind of helps us out here. So we see that we're going to slide our figure over, and so that would be a translation. And then it looks like we flip our figure over this line to become figure B, and that would be a reflection. So now we're going to practice actually translating a figure. So we have figure ABCD, and it has these vertices, so it's already plotted here for us. We want to sketch the new figure ABCD and its image after a translation of, we're going to we're going to add 5 to our x value and subtract 2 from our y value. All right, so if I do that, our new coordinates then would be, so I'm going to take this coordinate here, and I know the x is add 5, which means I'm going to move 5 to the right, so 1, 2, 3, 4, 5, and then y is minus 2, which means I'm going to drop it down to 1, 2. Plot my point there. All right, I'm going to do the same thing with this coordinate. I'm going to move it over to the right 5 and down 2, so 1, 2, 3, 4, 5, and then down 2, 1, 2. Let's look at this coordinate here. I'm going to move 5 to the right and down 2, so 1, 2, 3, 4, 5, and then down 2, 1, 2. And lastly, I'm going to move this coordinate over 5 to the right and down 2, 1, 2, 3, 4, 5, 1, 2. And now I could connect this, and there was my translation. A reflection over the x-axis, so flipping a figure over our x-axis, what we're going to do is just change the sign of y. So if our original coordinate is xy, it would now be x negative 1. So for example, if I had 1, 2 as my coordinate, the new coordinate would be 1, negative 2. Reflection over the y-axis, so taking our figure and flipping it over the y line, we're going to change the sign of x. So for example, if I had the coordinate 1, 2, I'm going to change the sign of y, which would be negative, or of x, which would be negative 1 in this case, and keep the y value the same. All right, so let's perform a reflection in the x-axis. So from the previous slide, if we're reflecting over the x-axis and we have the coordinate x, y, we are going to change the y. So it's going to then be x negative y. So let's do that to all of our coordinates here. So L prime then is going to be negative 2, negative 1. M prime is going to be 1, negative 4. And N is going to be 4, Now, 0 cannot change to a negative, so this one's actually going to stay just as 0. That's the only number where you can't change a sign because 0 is neither negative or positive. So that coordinate is going to stay exactly the same. So now let's plot these. So -2, -1. And if we look, those are the same distance from the x-axis, so that's good. 1, -4, 1, 2, 3, 4. And once again, this coordinate and the new coordinate we just drew is the same distance from the x-axis, which is good. And then finally, for 0, it's the same coordinate. And so if I sketch this, we have a reflection or a mirror image of each other. Rotation. The rotation is just a turn. So a figure is turned about a fixed point called the center of rotation. Clockwise rotation is negative, so going in the position of a clock, and then counterclockwise, going opposite of a clock, rotation is positive. If you rotate something 90 degrees counterclockwise, we are actually, if you look at your original coordinate, we're going to flip the x and y value around and make the y value negative. So for example, if I had the coordinate 1, 2, I'm going to make y negative, so 1, -2, and then I'm going to flip those two coordinates around, so -2, +1. You would do that for all of your coordinates when you're rotating a figure 90 degrees counterclockwise. So let's practice doing this together. So we are going to rotate the triangle 90 degrees counterclockwise. So I'm going to write what we do with our coordinates, so x, y. It would be -y, x. All right. So this coordinate here would be -1, 2. So I would negate the y and flip the x and y around. Our new coordinate for b would be -4, 2. So I would negate the y and flip x and y around. And then finally, I would have -1, 6. We would just negate the x value and flip the x and y coordinates around. So now I need to plot this. So I have -1, 2, 1, 2, -4, 2, 1, 2, 3, 4, 1, 2, and -1, 6, 1, 2, 3, 4, 6. So here's my new figure. So I took this figure and I just rotated it 90 degrees, and so now the triangle is standing up.